Okay, so for the last one we did 0, 90, 180, 270, 360. We drew a nice little graph from those and we had a look at the values for those using the unit circle. So going back to this beautiful circle again, you guys, as I said, need to draw this in your sleep and it becomes your best friend. 0, 90, 180, 270, 360. And remember, my little trick is you write down the pi over 2, pi, 3 pi over 2, and 2 pi. And then we draw these, which is based on vertically opposite angles, your X rule. And now we're going to have a look at these exact values. These exact values, we'll go through quickly how you get them. I think if you understand where you get them from, it makes remembering them that much easier. This one is based on an equilateral triangle, which has the angle of 60 degrees at each corner. And this is 2 units, 2 centimeters, 2 whatever. We then we bisect it with the perpendicular, so that goes out, and we halve the angle, so that becomes 30. We halve the side, and that becomes 1. Now, using your beautiful Pythagoras' theorem, we have a right angled triangle, 2 sides to find the third side. I'm not going to go through that too much, but you know my little rules, which I will tell you a bit later. C, A, and B. So C squared, which is a hypotenuse, is A squared plus B squared. My A is A, my B is 1, and my C is 2. This is another thing I'll be pushing very hard, is the setting out. I've got my 6 steps for any problem in chemistry, physics, and maths. This is part of it. Draw it, label it, formula. On the right-hand side, you write down your variables. Then you substitute those in. So 2 squared is equal to A squared plus 1 squared. I always write this first and then I rearrange. This goes on that side, so it becomes A squared plus 1 squared equals 2 squared. And I don't solve till the last line. Move that across with a minus 1 squared. We all know what 1 squared is, but I'm going to write it anyway, is equal to the square root of 4 squared. Oop. 4 minus 1, which I jumped ahead there, sorry, I'll try that again. So then you get A squared is equal to 2 squared minus 1 squared. Move that across, very basic, which you guys all should know, which is square root 3. Now I write that as root 3, which is next to the 30. That just shows you how to get that. You should all know that by now. So there's your 60 and 30. Likewise, with the 45, we use an isosceles triangle with 90 degrees, so that has to be 45. And that has to be 45. And this is based on the 1 unit circle, on the 1 unit. So 1 and 1, and with Pythagoras, that becomes root 2. So now 30, 60, and 45 are my little trigger angles. As soon as you see anything of that, or we'll get to the other 3 there, you straight away know you can use this, because we know that sine of 60, opposite over hypotenuse, opposite is root 3 over 2. Cos 60, likewise, is adjacent over hypotenuse is 1 over 2, and tan 60 is opposite over adjacent, which is root 3 over 1, which is just root 3. Then we also know sine of 30. Now remembering 60 is pi over 3. 30 is pi over 6. So sine 30, opposite over hypotenuse. And if you have a look, 60, which is the complement, it's a complementary angle with 30 to give 90, you get 60, the complement is 30, they're both the same, which we'll have a look at a bit later as well. Cos 30 is going to be root 3 over 2, and tan 30 is 1 over root 3. Now having the surd on the bottom, we know is a no-go. Some textbooks will leave it like that, but technically 1 over root 3, we don't like a surd on the bottom, so we multiply by root 3 over root 3, which is just 1. And again, this is just some basic stuff. The square of a square root, they cancel out and you're just left with 3. So here I get root 3 over 3, which is the nice way of writing that. So you guys should remember all that. So I'm just going to write 1 over root 3 here, which is root 3 over 3. And then we got 45. Again, these are you're going to write in your sleep. And it's 1, 1, root 2. And pi over 4 is 45. So you go sine 45 is opposite over hypotenuse. And again, we don't like the surd on the bottom. So that becomes root 2 over 2. Cos 45 is going to be exactly the same. Root 2 over 2, and tan 45 opposite over adjacent is 1 over 1, which equals 1. So these you should be able to work out like that all the time. Draw those, memorize them, and just write them down continually. So now we're going to come back to here. This you should know, when we're doing these, that's from there to there. So it's just 0 plus your theta. This one in this quadrant, remember that's quadrant 1, quadrant 2, quadrant 3, quadrant 4. All students take chemistry. When I was at school, it was all stations 2 central. But these days they do all students take chemistry. Important thing is all is positive in quadrant 1, only sine is positive in quadrant 2, only tan in quadrant 3, and only cos in quadrant 4. Now if we remember going back to the 0, 90, 180, 270 and 360, and we had a look here, and that was 1, 0, that was 0, 1, that was minus 1, 0, and that was 0, minus 1. Now when we do opposite on hypotenuse, we see that in this quadrant it's a negative x and a positive y. So y is the sine value. This one, it's a negative y, but a positive x. So that's why cos is positive. And remembering tan is a negative over a negative, which makes a positive anyway. So going back to here, the big thing to remember, especially when we did them from minus pi in the last one, this goes from there to there. It's not from here to here. It's from there to there because there's my theta. And this one is always 180 minus theta in that quadrant. Quadrant 3, we're going down this way for theta. Not from here up, we're going from here down. So I always write those there. When we're here, quadrant 2, 180 minus theta. Quadrant 3, 180 plus theta. And here we're going down from here down, which is 360 minus theta. We're not going from 270 up, it's there. Sometimes they trick you and give you this angle, but you have to do that angle. So when we look at this, this is where the other trigger values come in. We know 30, 60, 90. Some teachers draw a table up and make you memorize a table. Waste of time and it's confusing. All you need to know is here, let's try quadrant 2. If we make theta one of 30, 60 or 45, it will be 180 minus 30 is 150. 180 minus 60 is 120. And 180 minus 45 is 135. These are your nice trigger values. You can work out using your exact values with 30, 60, 45 in quadrant 1. Quadrant 2 is 150, 120 or 135. So let's just have a look at cos of 120. Now I know 120 is less than 80, so it's in quadrant 2. I like to write it like this. That's the same as cos of 180 minus 60, and I write the 120 up here. Now if you're doing it in radians, we'll do one of those a bit later. This means, well, cos in quadrant 2, I write quadrant 2 here. Cos in quadrant 2 is negative. So it's the same as minus cos of theta, and in this case, theta is 60. So we just go back up to our exact value. We know that cos of 60 is a half. So the answer is minus a half. If it was sine of 120, it would be positive a half. If it was tan of 120, it would be minus root 3. So again, these values in the second quadrant. What about the third quadrant? It's going to be 180 plus theta. So if theta was 180 plus 30, it's 210. 180 plus the 60 is 240. And 180 plus the 45 is 225. Again, those values, if you see 210, 240, 225, it comes back to 30, 60, and 45. And tan is only positive in that one. I can go through some later. If anyone wants to, just make a comment and I'll do the each quadrant. But let's have a look at quadrant 4, which is cos is only positive. And again, it's those trigger values. It's 360 minus theta. So let's do 360 minus 30. It's 330, a trigger value. See, 330, we know we're going to have 30. 360, whoops, minus 60 is 300, another one of those trigger values. And 360 minus 45, whoops, is 315. So they're the trigger values. For example, if we did tan of 315, you just go to yourself, okay, that's the same as tan of 360 minus 45, which is 315. Tan in quadrant 4, because I'm here, is negative tan of 45, which is minus 1. Bingo, all too easy. So that's your 30, 60, 45, and in all your different quadrants. So that is working out your exact values in your beautiful little unit circle. So that will be for today. Practice drawing those all the time, checking those values out. They're the beautiful little values that we can then look at exact values. So I'll sign off, and my next one will be on looking at minus 2 pi to 2 pi. Thank you. Is that one